moving on to another unit or another section of the course. We're going to get into radicals now, radical expressions, and we're going to deal mostly with square root and cubic roots, although you could have a higher root. You should be familiar with some of this already from Algebra 1. Square roots, I mean, I think almost all of you know what square roots are, but there is definitions here for you. So, for example, radical 25, square root of 25 is 5, because 5 times 5 is 25. This is the key and what we're going to be looking for when we simplify these radicals in this lesson. See how it's 5 times 5? That's important. That creates 25. All right, so we write just one 5. When you see a pair of identical factors, you write just one of them, and that's what is the square root. And then here's a cubic root, for example. What's the cubic root of 64? Instead of thinking, and you may not have done a lot of cubic roots, but instead of thinking what number times itself twice, by the way, you might have been thinking 8. You might have said, oh, it's 8. No, it's not. Because a cubic root is what number times itself 3 times gives you that number under the, it's called in the radicand, okay? 64 is called the radicand. What number times itself 3 times gives you that number in the radicand? Well, it's not 8, because 8 times 8 times 8 is not 64. So it wouldn't be 8. It is 4. 4 times 4 times 4 is 64. 4 times 4 is 16, and 16 times 4 is 64. So 4, see how there's 3 4s? 3 4s make a 64, therefore 4 is the cubic root of 64. This is the thought process you want to have when you go and simplify cubic roots, because we're going to be getting into radicals that are not nice. They're not nice perfect squares. See, 25 is called a perfect square, and 64 is a perfect cube. We're going to be simplifying radicals that are not perfect. All right? So this is the key to it. And I just put definition of square root, but cubic root's the same thing, except it's 3 factors. Definition of square root. Radical r, square root of r, is defined as one of the 2 equal factors. That's the key right there. One of 2 equal factors. One of 2 equal factors whose product is r. So, for example, back up here. 2 equal factors, 5, 5. The product is r, 25 in this case. All right? And therefore, the square root is 5. So the answer to radical 25 is just 5, plain old 5. Keep that in mind. Now, when we go to simplify radicals, again, it's all going to be about these groups of equal factors. And I'm going to keep going back to that. Groups of equal factors. It doesn't matter if we're doing square root or cubic root. Square root, we're going to look for 2 equal factors. Cubic root, we'll look for 3 equal factors. We're going to get into variables. It doesn't matter. Okay, y times y squared, y times y cubed. All right, so that's kind of the stuff we're going to be looking for. Here's all your notes on how to do it. We're mostly going to focus on this first condition here. We're going to get right into these examples for you. So 5 square root of 63. I can't take the square root of 63. It's not perfect. So this is what you're going to do. The 5 we're going to ignore for now. We're going to break this 63 up. And you can factor it however you want. The beauty of this is you could factor it however you want. We're going to use factors. So 63, I'm just thinking, okay, 9 times 7. That's the first thing that popped in my head, Mr. Ventry's head. Is that the first thing that popped in your head? It doesn't matter. Whatever popped in your head, you write it down. Because you can keep breaking it down. I'm going to break down my 9. I could break it down 3 times 3. And now I'm done, because 3, 3, and 7 are all prime numbers. This is my prime factorization. You may have learned it. That's the terminology, prime factorization. 3 times 3 times 7, and that gives you 63. What you're looking for are those groups or pairs of identical factors, because we're doing square roots, pairs of identical factors. 3 and 3. Circle it. Because I have that pair, that represents just a 3. Just like up here, where we had 5 times 5, right? That represented a 5, just a 5. So that's what we're going to be doing. We're going to take that pair and make it just a plain old 3. Now, so what do we have? We have the 5 that was already outside the radical. We have a 3 from this, times 3. and then a leftover 7. The leftover stays back in the radical because we don't have a pair with it. We can't take it out of the radical unless we have a matching pair because it's not perfect. The 9, it turns out, see how the 9 went down to 3, 3? The 9 was a perfect square. So that came down to just a regular 3. But the 7 had nothing, couldn't be factored anymore. So it had no identical pair, so we couldn't do anything with it. So I'm not going to explain these like in depth, but that's kind of the idea. And it's going to be 15 radical 7 for our final answer. The 5 came from the original 5. The 3 came from the pair, and then the 7 stays in. Okay, so for number 2, 98 we can break down, let's see, 49 times 2. And then I have 7, 7. And there's my pair of 7s this time. The 2 has to stay in because I don't have a matching 2. How about the C's? This is how we're going to write out the variables. We're going to go C, 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 C. C to the 4th is C, 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 right? 4 C's. Look for pairs. How many pairs do we have? We have one pair here, and we have another pair here. We have 2 pairs of C. That's a C and a C. So it's going to give us a C squared. I have a 7 from here, 7 C squared, and then I have a radical 2. So 7C squared radical 2 would be our simplification. All right, here, 200. 100 times 2. First thing that came to my head. 100 was 10 times 10. And I can't go any further. So I'm going to go, well, I could go further. I can go 5, 2, 5, 2, but I already got my pair. If I got a pair, I might as well stop. All right? Because if you go further, you're going to have 5, 2, 5, 2. You're going to have a pair of 5 and a pair of 2s. 5 times 2 is 10. You get the same answer. So I would just stop right here if I was you. 2 does not have a pair with it. And then the y is y, y, y. All right, so I have a pair of y's. So what do I have? I have a 3. I have a 10. I have a y that came out. And then I have a leftover y and a leftover 2. So I have a leftover 2y. That just goes right back in the radical. Whatever the leftover is that doesn't pair up with anything goes right back in the radical. 30y radical 2y. 30y radical 2y is our simplified radical. All right, here I got 72. 36 times 2. 6 times 6. All right, there's my pair. I might as well stop because I can go down 3, 2, 3, 2. But again, it's going to be pair of 2s, pair of 3s. So no sense in doing that. This is A, and then I got B, 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 B. All right, I need pair. Let's see. I'll change colors here. I have a leftover 2, don't forget. I have a pair of A's. I have a pair of B's and another pair of B's. I have a leftover A and a leftover B. All right, so let's see what I have. I have a 6. Don't forget the 1/2 that's already there. So 6 times 1/2. I have, I already did that. I already have an A and I have a B and a B. So I have AB squared. So 2 pairs of B's. That's B squared. And then what's got to stay under the radical? A 2, an A, and a B. All right, so, this is 3. So that's going to be 3AB squared radical 2B. 1/2 times 6 is 3. That would be your final answer down there. So now we got cubic roots. Same thing, except you're looking for groups of 3 instead of pairs. So 40. We'll break it up 10 times 4, first thing that popped in my head. And then this is 5 times 2. And then this is 2 times 2. And there it is. Look at. We have 3 2's. That's a 2. That's just a 2 as a cubic root. So we're just going to write a 2 in our answer. And then this is the leftover, so that stays under the cubic root radical. We have a 5 left over, so 2 cubic root of 5. That's it. It's that simple. 16 is going to be 4 times 4, first thing that popped in my head, and then I can go 2, 2, 2, 2. I have a group of 2's, so that gives me a 2 again. And I have a leftover 2. And then I have x, 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 x. I have 3 x's. I need 3 of them. And I have a leftover 2. All right, so I have 2. Then I have an x. That's just an x. 3 of them make 1. Okay, 3 of them make 1. And then that's left over. So then, or that's what comes out. Then left over is 2 and an x. 2 and an x squared, actually. I have 2 left over. Those are both left over. Okay, so actually I should put these in 2 different boxes. All right, so 2x is left over there. How about a fourth root? All right, so 120. We have 60 times 2. And then we have 30 times 2. And then we have 15 times 2. And then we have 60 times 2, 30 times 2. And then we have 15 is 5 times 3. All right, so we don't have anything here that can simplify. I can't simplify 120 at all. All right, I don't have 4 of them. I don't have 4. But how about x to the 9th? I have x, 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 and then I have a leftover x. So I have 1, 2 x's that can come out. So I could take out x squared. That's all I can take out, and then everything else has to stay in the fourth root, 120x with a leftover x there. So I have a 120 is all left over. I don't have enough to go down. I only have 3 2's. I don't have 4. Okay, so I can't go any further. 120 x squared, fourth root of 120. Now back to cubic roots, but I have binomials. So this is x plus 5, 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 x plus 5. There's 7 x plus 5s, basically, is what it's saying. Well, how many of them? I need 3 of them because I'm doing cubic root. So I could take out 2x plus 5s, 2x plus 5s. So I'm going to write that as x plus 5, and I'm taking out 2. 2, I need 3 to make 2. All right, so that's 2. And then in the radical remains a leftover x plus 5. You could put that in parentheses, but you wouldn't have to. You could just leave it as x plus 5. So that's kind of a weird one, but you can think of, binomial factors. All right? Now, we're going to get into adding and subtracting radicals, and we're going to do this part in class because the video, you got the simplifying part. Adding, subtracting is just simplifying, except then combining after you simplify. So we're going to do this part of the lesson in class tomorrow. But we had a nice start here that's kind of saved us some time. I'll see you then.